So let's talk about a couple of HSM attacks. So the simplest one to understand is what's called the wrap decrypt attack. So this is one of the attacks from Jolly and Clulow's 2003 CHES paper. And it relies on a very simple piece of functionality inside the PKCS 11 interface that's called wrapping. So key wrapping is simply a jargon way of saying I'm going to encrypt one key with another key. So why might you want to do that? One reason would be to store the keys offline if you need to do that, and another might be to exchange the key with another HSM, so you've both got the same key, but you want to transport the key to the other HSM encrypted. You don't want to expose it in the clear. You might want to spread keys around different HSMs to do load balancing. There's a whole bunch of good reasons you might want to do it. So it's a good piece of functionality to have inside the HSM, the ability to encrypt one key with another. If you want to encrypt one key with another, you have to tell the HSM that you want permission to do that. So you have to say, here's a key that I want to be able to use to encrypt another one, and I'm going to give that the wrap permission. So this is the attribute that's called CKA wrap in the PKCS 11 interface. And then the key that you're going to wrap, so the sort of payload for this operation, has to be marked as a key which is extractable. So this means you set the CKA extractable attribute in the PKCS 11 interface to true on that key. So now you just call the operation and you say, I want to wrap the payload key with the wrapping key, and what you get as a result is that payload key encrypted with the wrapping key and everything is fine. Now, for the attack, what you do is something a little bit sneaky. You tell the HSM that that key that you're using to do the wrapping, you also want to use it to do decryption of ciphertext. So this is another operation that the HSM will let you do, completely normal thing to do. Here's a bunch of data, decrypt it, give me the result. Okay, fine. So you set the permission on the wrapping key for decrypt to true. So the attribute CKA decrypt is now true. But now all you do is you take that nice wrapped, sensitive, important key that you got from your first operation, you send it back into the HSM and ask the HSM to decrypt that ciphertext for you. And the HSM checks that you've got the decrypt permission on your key, which you have, so that's great, and it spits out the plain text value of your sensitive payload key. So this is the wrap decrypt attack. A very, very simple way in 2 operations you can read the value of a sensitive key from an HSM. And if you set up an HSM by default without changing anything, this works pretty well on a whole bunch of the HSMs which are out there, all of which have FIP certificates and certifications and all that kind of stuff. So Jolly and Clulow's wrap decrypt attack applies to keys which can be wrapped by another key, so they have to be marked as extractable. So what about attacking keys which are marked as unextractable? Is that possible? Well, yes, it's possible in several different ways. So one way that Jolly and Clulow explained how to do it back in his paper in 2003 was using key derivation. So there's a method for key derivation in PKCS 11 called extract key from key. So this is a strange idea, but essentially what it means is I'm going to take a long key value that I have and chop out some of the bits as a short key value and use that for another operation. So the reason that you can use this to make an attack is that while you might not be able to brute force guess the value of, say, 128 bits key, because there's just too many possible values, you can quite easily brute force the value of, say, 40 bits of key. So the way you make your attack is you first ask the HSM to generate for you a key extracting 40 bits of information from an unextractable key that's already there inside the HSM. So it makes you a new key that's only 40 bits long. And then you do something like use those 40 bits as a key for an HMAC, say, and you HMAC the string 0, let's say, with this new key, and now you've got the result of that HMAC outside the HSM. So now what you're going to do is you're going to brute force guess those 40 bits. So on your own, in your own software, without touching the HSM, you just keep HMACing 0, and you guess all the possible values for the key, for the 40-bit key, until you get a hit. And once you get a hit, you know you've got a correct guess for those 40 bits. So that's 40 bits. There's 128 bits to guess in the target key, but that's fine. You can just repeat the operation for the next 40 bits of the key, then the next 40 bits of the key, then the next 40 bits of the key, and then the last 8. And then essentially you're done. You've cracked a 128 bits key for less effort than 43 bits. So you've basically saved yourself a lot of time, and this very, very smart, nice key that was marked as unextractable is now known in the clear outside the HSM. So again, we've only used a couple of operations from the HSM stack. We've used key derivation and an HMAC call, and this attack's been known about since 2003, but it really does work. It works on a whole bunch of HSMs out there, and it was the subject of a CVE back in 2015. So it's something you really have to check on the HSM configuration that you use.